Way 63 talks about calculating the gram formula mass of a particular compound. In order to do this, you're going to have to take the sum of the atomic masses of the atoms. Please note that for the atomic mass, it's provided for you on the periodic table at the top left-hand corner for each element. So every atom of carbon will supply a mass of 12.011. Typically, you don't need to be this precise when you do the calculations for atomic masses. You can simply round this number off to the nearest whole number, and that will be sufficient. But for the purposes of precision, I'm going to show you how it would be calculated using the exact values. Let's try some problems. What is the gram formula mass of calcium hydroxide? Now, please note that you need to count the total number of atoms present in this compound in order to correctly calculate the atomic masses. So please note that this 2, which is enclosing this parentheses, is modifying every atom inside it. So that means that there is a total of 2 oxygens and a total of 2 hydrogens present in this compound of calcium hydroxide. Looking up the masses of calcium, you'll find that calcium has a mass of 40 grams, oxygen has a mass of 16, but there are 2 of them present, and hydrogen has a mass of 1. So when we multiply each of those values out, we get 40 from the calcium, 32 from the 2 oxygens, and 2 from the hydrogens, which would give you a total of 74 grams per mole of calcium hydroxide. Please note that formula mass is written in terms of units of grams per mole. That means every mole of calcium hydroxide has 29 grams present. The unique odors and flavors of many fruits are primarily due to the small quantities of a certain class of organic compounds. The equation below represents the production of one of these compounds. Here we have reactant 1 plus reactant 2 gives you product 1 and product 2. Show a numerical setup for calculating the gram formula mass for reactant 1. In order to calculate the gram formula mass for reactant 1, we need to know its formula. So we have to write the formula for the compound. Notice that there are 2 carbons present, 5 present here connected to these carbons, 1 oxygen, and 1 hydrogen. So the formula would be C2H5OH. So we would need to find the mass of each element in the compound. If we do that, carbon's mass has a mass of 12.011 grams per mole, and since there are 2 present, that would take us to 24. 6 hydrogens would give us an atomic mass total of 6.004764, and 1 oxygen present means an atomic mass of 15.994. Add up all the masses, we get a total mass of 34.021 grams per mole. You could simply, for the chemistry regents, we technically allow credit for 34 grams per mole because significant figures do not need to be shown unless specifically asked for in the problem. So you could just simply write 34 grams per mole because each one of these values would round to, this would round to 12, this would round to 1, and oxygen would round to 16. So when you add up all the values, you get 34 grams per mole, and that would be sufficient for the gram formula mass of reactant 1. The formula mass of a compound is the... You should eliminate 3 and 4 off the bat because gram formula mass has nothing to do with product. And you know that it's not the sum of the atomic numbers, it's the sum of the atomic masses of each atom present in the compound. So choice 1 is correct. Given the formula for heptanal, determine the gram formula mass of heptanal. And given the structural formula, we need to count the total number of atoms present for each element to get its molecular formula. Doing so will tell you that there are 7 carbons, 14 hydrogens, and 1 oxygen present. In order to calculate the gram formula mass, simply multiply 12 times the number of carbons, 1 times the number of hydrogens, and 1 times the mass of oxygen. Doing that will get you a total mass of 114.18216 grams per mole. Again, the regents would allow credit if you just merely rounded to the nearest whole number. So 114 grams per mole would be sufficient for this answer. Remember, significant figures don't need to be shown unless specifically asked for in the problem. So you can get away with, for the most part, rounding the atomic mass of each element present to the nearest whole number. In 1828, Frederick Wohler produced urea when he heated a solution of ammonium cyanate. This reaction is represented by the balanced equation below. Ammonium cyanate heated will turn into urea. Determine the gram formula mass of the product. Looking at a chemical equation, the product tends to be on the right side of the arrow. Reactants are on the left, so we're asked to calculate the gram formula mass of the product, in which case we need to write down its formula or simply count the number of atoms present. There are 2 nitrogens present, each with a mass of 14 from the periodic table. 1 carbon present gives you a mass of 12, 1 oxygen, mass of 16, and the 4 hydrogens in this molecule will give you a total mass of 4. Adding up all the masses will sum to 60 grams per mole. So when it comes to calculating the gram formula mass of a particular formula, make sure that you have the formula from the get-go. If you're provided a structural formula, you're going to need to count the total number of atoms present and multiply that value by the mass written on the periodic table, sum up all the masses, and then you get the total gram formula mass. Thank you for watching.